there is a positive charge is there. Now between these two Coulombic interactions are possible. Whenever negative positive is there, adjacent, there will be chance of Coulombic forces or electrostatic forces will be formed here. Now between these two, hydrogen bonding is possible. This is covalent bond because it is in the molecule a covalent bond is formed. Now here it is what is happening between the molecules. Now this molecule may be same or different. That I will explain later. So what I mean to say, fluorine and hydrogen, they are not belongs to what same molecule. Hydrogen, you read in textbook what is the definition they given. They simply said hydrogen from one molecule, fluorine from other molecule. Correct or not? You read textbook what happened, definition, you see fluorine and hydrogen. Again similarly what happened, fluorine, hydrogen, again positive character, negative. Now I am saying here what happened, this is covalent bond. This is what actually covalent bond. This one is what actually hydrogen bond. Correct? Now understood here. Covalent bond, how it form covalent bond? By contributing electrons equally and sharing the electrons also what equally, we get a covalent bond. Here nothing is actually contributing. Here we don't have any electrons beta. Here we don't have any type of electrons here. In hydrogen bonding, we don't have any electrons in participating in the bonding. No. Only because fluorine got negative, hydrogen got positive, what happened? That is the reason we got hydrogen. Now in this place of fluorine, we can take what happened? Oxygen, we can take what happened? Hydrogen. Now you take HF, water, and ammonia. All these three can form hydrogen bondings. They can form hydrogen bonding. See, fluorine, oxygen, nitrogen. All these three can form hydrogen bonding. Any doubts regarding this? Regarding hydrogen bonding definition beta?
No, sir.
Right. Hydrogen bonding, how it is referred at? You have to represent dot line like. Actually, you have to put 3 dots. No need to put many number of dots. Putting 3 dots indicates, this dot line indicates what actually? It is a hydrogen bond. Covalent bond is represented as a straight line like this, a line like this. But hydrogen bonding is represented by dotted lines like this. Okay. Now, the physical state, if you observe what happened, generally when you have hydrogen bonding, they compress together. So if it is a gas, will convert into solid. Liquid will convert into solid. When you observe what happened, ice, strong hydrogen bondings, it is a solid nature actually. There are 2 types of hydrogen bondings. There are 2 types of hydrogen bondings. One is called intermolecular hydrogen bond. Inter means what? Within the molecule, between the molecule, between molecule. Intra means what? Within the molecule, within the molecule. So 2 types of bondings will be there: inter and intramolecular hydrogen bondings. Here 2 types are there. Let us take first of all intermolecular hydrogen bonding. Intermolecular hydrogen bonding takes place between the 2 different or same molecules here. So let me see this one, different and same. Let me see. Now ammonia, you see, I have taken ammonia. Now definitely nitrogen will get a negative character, right? Hydrogen will get a positive character because of what? More electronegativity. Nitrogen is more electronegative than the hydrogen. Now same thing, positive character, negative. Same thing, positive character, negative character. That means it can form a hydrogen bond. It can also form hydrogen bond. Similarly, oxygen will form hydrogen bonding with hydrogen. Will form. Now these 2 are same molecules. That means the hydrogen bonding is forming between. That means the hydrogen belongs to different molecule and nitrogen belongs to, you see, nitrogen belongs to different molecule, hydrogen belongs to different molecule. Correct or not? Now when they are forming hydrogen bonding, they can form hydrogen bonding with same type of molecule. See, with ammonia, with alcohol, with water and water, they can form hydrogen bonding. So this is between the molecules. Now this is what hydrogen bonding of ammonia. And what happened? Alcohol. You can write with water also like this. Let me see what happened. This one also let me see. Same or different. We can also write hydrogen bonding like this also. Water I am taking. Okay. I am taking ammonia. Now hydrogen bonding here also possible. Correct? Now hydrogen bonding is taking place between different molecules. See? Different. One is what? Water. Other is what happened here? Ammonia. Or you can take like this also. Some more examples also you can take. Alcohol, ROH. This is the alcohol. Next, water I am writing. Water. Water. This is water. Now between alcohol and water, what type of bonding is there, beta? Alcohol and water, what type of bonding is there?
Hydrogen.
Hydrogen. That too interhydrogen bonding. That too inter, between the molecules, between the different molecules here, between the two different molecules. See, between the two different molecules here, between the same molecules. Now this is the reason alcohol is highly soluble in water. Why alcohol is soluble in water? If they ask any question, you have to give because of hydrogen bonding here. Because of hydrogen bonding. Now which is having strong hydrogen bonding? HF stronger than what happened? Water. Water stronger than what happened? Ammonia. This is because of fluorine will form have more electronegativity. Okay. So which elements are forming hydrogen bonding beta? Fluorine, oxygen, nitrogen. Remaining they can't form hydrogen bonding because they are less electronegative. Next we'll move to what here? Intramolecular hydrogen bonding. Intra means within the molecule. This type of hydrogen bonding is found within the molecule. See, within the molecule. I have taken orthonitrophenol. Orthonitrophenol. Now this is only one molecule only. Everything is a one molecule. I have taken like this. Everything is what? Only one molecule. C N double bond O. Okay. Here it is what? O. And this one is what? OH. Now definitely oxygen will have more electronegativity. Hydrogen will have electropositivity. Now definitely between these two, we are going to get the hydrogen bond. Understood or not? You observe here what happened? This entire one molecule only. Entire one molecule only. But the hydrogen bonding is possible between oxygen and hydrogen like this. This also takes place like this. This is called intrahydrogen bond. But this is weak. Why weak? Because this is forming in the molecule. So not having any type of forces between the molecule. When forces are operating between the molecule, then it will be strong actually. Within the molecule, what happens? Nothing will be there. Right? So orthonitrophenol will exhibit what type of bonding beta? Intramolecular hydrogen bonding. Isn't it? We take one more example here. This is salicyl aldehyde. Salicyl aldehyde means I am writing like this. C double bond O. C double bond O. And this one will be the OH. One molecule, salicyl aldehyde. Now put here what happened? Hydrogen bonding over here. Now what are the examples you have taken here? Orthonitrophenol, salicyl aldehyde. They can be taken as what? Intra-hydrogen bonding. Right? Important points if you observe what happened. Hydrogen bond, in the formation of hydrogen bonding, there are dipole-dipole attractions at opposite side. Dipole-dipole attractions means like this. If you take what happened, HF, here we are getting hydrogen bonding because of what? Negative character over here, positive character over here. So dipole attractions are present in opposite sides. Hydrogen bond formation never involves more than the two atoms. When you have more than two atoms, that means hydrogen bonding is present between these two atoms only, no? Strength, if you observe, fluorine is not more electronegative than oxygen. This is the order concept. This is strength. Okay. Now, when you're writing, what happens that you have to place on one plane only. When you're writing hydrogen bonding, place these one plane only like this. Hydrogen bonding may exist in solid space. For example, ice, liquid phase, water. In solution means what happened? I've taken just an alcohol in water. Alcohol plus water. Solution state it is. Or maybe exists in the gas phase also. Gas phase means what happened? HF, isn't it? It is a liquid actually, but you can take vapor also. In vapor also it will exist, no problem. Strength, if you observe what happened in hydrogen bonding will be strong in solidness. That means if anybody asks you ice, water, and vapor, water vapor, okay, water vapor. In which case hydrogen bonding is strong? In solid state. Ice is having strong hydrogen bonding because they compress, no, they come near, no, that is the reason actually. So this is extra information for you. That is no need for you. Right, let me take now, move to our textbook here. Now this already we discussed now. That hydrogen bonding definition we completed. And types also we completed. Inter and intra. Inter, example, you observe here, HF we have taken. And intramolecular hydrogen bonding we have taken. Isn't it? Orthonitrophenol. I have taken one more thing. Salicyl aldehyde also I give. Salicyl aldehyde also I give. Correct? All of you please note down the example and what I have written. Okay, all of you please note down in your textbook, notebook actually. Right? Only 1-2 questions are there. We'll discuss that one also regarding the hydrogen bonding. This one. Define hydrogen bond. It is weaker or stronger than the van der Waals forces. Hydrogen bonding is stronger than the van der Waals forces, but weaker than what? Ionic and covalent bond. Hydrogen bonding is weaker than ionic and covalent. This will get in the next chapter. Okay, this is about the hydrogen bonding data. With this, what happened? We have completed the hydrogen bonding. Understood better, all of you? Any doubts you're having?
No,
No
sir.
doubt, sir.
So